record. All right, so let's take a look at one-to-many relationships and how maybe not to set up our data. So how might we represent information in our database? So let's say that an author has many books. How do we set that up in a relational manner? Now with Mongo, again, we probably would have created an author document and then embedded each book on that author document. But with relational databases, we want to set it up a little bit differently. So let's assume for this example that each book has only one author. Although this is not always the case in the real world. You know, sometimes you'll have 2 or 3 authors or a ghostwriter or something. But so in this option 1, this is an incorrect way to potentially set up your data. It's a little inefficient. And it's because if you look at the authors field, so we have name, nationality, and birth year. And then on our books table, we have fields of title, that's great, publication date, sure, the author name, okay, the author nationality, and the author birth year. So why is that not an efficient way to set up our data? Well, it kind of says it right there in the downside. So it's duplicating data. So we already are storing author nationality and author birth year and even author name on the author table. So we don't need to duplicate, we don't need to store that data on the books table as well. The only thing we would need in our books table is a foreign key for that author. So if an author has 10 books, is it going to be more efficient to store the IDs of all of those 10 books on the author? Or is it going to be more efficient to go into each book row and just put the ID of the author that it belongs to? So the idea is that when you have a one-to-many relationship, you want to put that foreign key on the many entity. So we would just create an author ID field on book and put the author ID that it belongs to. That would be the idea there. Let's take a look at another example. So here's another way we could think about setting up like books and authors in a database. So this would be creating an array of IDs. So I think maybe Alejandra's example was somewhat similar to this. So let's say that we set this up. So we had an authors table, and the authors table had columns or fields, the author name, the author nationality, and maybe we have a book IDs field that's like an array of IDs. And then maybe on books, we have a column of title and maybe a column of publication date. So one reason that this is inefficient, relational databases are not great at storing objects, at storing like arrays or objects inside of a column. That's not what they're built for. Now Mongo is really great at that, right? We can just throw embedded objects into embedded documents all day long. But relational databases aren't really set up for that. And it says here, parsing the list would be a nightmare, and it can't index an array inside of a table very well. So it's not an efficient way to take advantage of a relational setup. So again, what we could do, instead of storing all of those book IDs on an author, we could just create an author ID on our book and put the ID of the author that book belongs to. So no ng repeat. No, you can definitely do an ng repeat, but you just don't need to store an array of anything in relational databases. You would set it up with the foreign key relationship. And then the final way, so this would be kind of the idea way to set up books and authors relationship. And again, this is just demonstrating kind of a one-to-many, which is a very common way to set up your data. So this would be a really nice way to set up these entities. So the authors will have that author ID, which is the primary key for an author, and would also have name and nationality fields. And an author has many instances of a book. So then on our books model or our books entity, the book has a primary key of its own, right? It has its own books ID. Then it has title and publication date. And then we can store the author ID for the author that that book belongs to. So that author ID field is the foreign key. That's what it's considered. So every entity has its own primary key, but the really important thing is where do you put the foreign key to set up that relationship? So this is how we would do it using a relational database. We'd put the foreign key, an author ID foreign key on our book, and that makes it super fast to find data. So any questions about this? This is just a one-to-many. Tomorrow we'll take a look at many-to-many, or you know, doctors and patients, and they have many a patient has many doctors, a doctor has many patients, because they all share given appointments, which is kind of like the connecting tissue between those entities. There's a lot of really interesting ways to set up your data.
I have a quick question.
Sure.
So I'm not sure if this is the ideal way to think about it, but I guess with the relation with relationships, the idea is to think about these things more like individual pieces that have these relationships versus, like, I think with Mongo, it was kind of like thinking about like a pyramid kind of scheme, like one thing that kind of, and it schemes off this other things, like the embedded documents. This one is a little bit different, I guess. So everything is this individual thing, but they may or may not have relationship to something else.
Correct. Yeah, this is an entirely different way of thinking. So Mongo is a non-relational database. So yeah, we could create documents, and then the way that Mongo's set up, the way that it is really efficient is, let's just, for example, if we had an author document in Mongo, let's just store book documents directly on the author. So we would only have one collection in Mongo. We'd have an author's collection, and then every book document, we're just going to store it directly on that author. But a relational database is an entirely different way to structure your data. And so we need to play within that sandbox. So each entity is going to be its own table. So the data has integrity and separation. So we'd have a books table, we'd have an authors table, so they're separate. And the way that we connect them is putting a foreign key on one of those entities. And so since an author has many books, the most efficient way to set that up is just put the ID of the author on the book, that the author that wrote the book. Just put that author ID field on there. Here's another example. Maybe you guys will recognize this. Another has one-to-many relationship. So again, with the relational database, all database records or the rows, so remember each row is an individual book or an individual author. These database rows are assigned an ID or a primary key. So every author has its own primary key, and every book has its own primary key. But when we put an author ID field on books, that's considered a foreign key, if that makes sense. It's really confusing, you guys, but you guys will get it. Records may then reference other foreign keys or keys from other tables to create these relationships between records. So here's an example, like a Harry Potter type example. So we have houses and we have students. So a house has many students, and a student belongs to one house, okay? So if we look at that houses table, the way that we'd set up the houses, so the houses has its own primary key field. So house number 1 is going to be Gryffindor, and it's going to have a red color. House number 2 is going to be Ravenclaw, house number 3, house number 4, etc. But in the houses table, that ID is the primary key for a house. Then if we look at the students table, so we have 4 students. That first column is the student ID. That's the primary key for each student. So the first student is Harry, second one is Ron, third one is Hermione and Draco, whatever. Now, how do we tell which student belongs to which house? Well, since a house has many students and a student belongs to one house, the way to set up this relation is to put a foreign key field on the student. So you can see that last column in that student table is that house underscore ID field, and that's considered a foreign key for the house. So this is how we can set up the relationship. So we can see that Harry Potter belongs to the house with the ID of 1. So Harry Potter belongs to Gryffindor. Ron also belongs to the house with the ID of 1, so he belongs to Gryffindor. Hermione belongs to the house of ID of 1, Gryffindor, and then Draco belongs to Slytherin. So the way that relational databases work, it's more efficient just to put that one column on the many versus putting all of those students on the houses. It's much faster to search and query when you set up your data this way with the foreign and primary key relationship. So sometimes this takes a minute to get comfortable with, but we're going to get a lot of practice with this. Let me ask you guys this, a little bit of a...
When you say efficiency, like actual performance of the search will run twice through?
Yeah, because with Mongo, we would store, for example, if we had a houses document, we would just create a student document and just dump the entire student document onto the houses document. And that works great for a document-oriented database because there isn't a schema. And the idea is like, if I'm gonna look in Mongo, once I find that house, all of those students are right there embedded on that document. So it's like one-stop shopping, right? All my data is right there. But with the relational database, each entity has its own table, right? They're all separate. So you're gonna have a table of houses, you're gonna have a table of students. And so how you set up that relationship is really important. So instead of dumping, let's say that there are, I don't know, 100 students to a house. It's not gonna be efficient to create an array of students on the houses because relational databases aren't great with like arrays and objects. It's not really built to do that. Now, if you did want to set it up like that, you'd probably want to use Mongo or some other non-relational database. But to set this up the way that relational databases are intended, we'd put a foreign key of house ID on the student. And so all we need to do is put that one ID of the house that the student belongs to. So this would be the most efficient way in a relational database structure. Again, it's the right tool for the job. I mean, you could totally do this in Mongo, but I found, listening to your, when you guys are walking through your projects, and you guys probably, in hindsight, a lot of your data actually would have worked better as a relational model. Since we're using Mongo, we tried to play within their sandbox and use those embedded documents. But, my group, for example, I know that they ended up using references at the end of the day. And if we were going to do your project over, Alan, Audrey, and David, if we were going to do that over, the best thing to do would have just to use a relational database. But since the exercise was to practice with a non-relational, that's why we use that. But, some data is just well suited for non-relational like Mongo, and some data is set up for relational, using Postgres, for example. So I just put a prompt into Slack just as a review. So describe the following relationships. Which table would contain the foreign key? So if I have an author table and a blog table, so an author has many blogs, which entity would have the foreign key? Would it be the author table or the blog table?
Wouldn't it be the blog?
Yeah, perfect. Yeah, since an author has many blogs, the way that we'd want to set up that relationship is create like an author underscore ID field in our blog table, and then just put the ID of the author for that particular blog. Nice. The second one, so let's say that a recipe has many ingredients. Well, I just kind of gave it away there. Let's say that we have recipe and ingredient entities. So recipe has many ingredients. So which table would have the foreign key? How would we set that up? Would it be recipe or would it be ingredients? I see Matt typing. So Matt, what do you mean by that? Ingredient or foreign?
So what I meant to say is very similar to the last example. A recipe has a lot of ingredients, so you can assign multiple ingredients, and that's why they are the foreign keys, right? Am I getting that mixed up?
Which table would have the foreign key on it, and what would that foreign key field be called? So recipe has many ingredients.
Gotcha. So the foreign would then be the recipe because each ingredient could be assigned to the recipe.
Nice. Yeah, so in our recipe table, we'd probably want to create like a recipe underscore ID field, and that would be the foreign key. So if a recipe has many ingredients, we could just put the ID of the recipe on the ingredient that it belongs to. That's kind of a tricky one because let's say that we have, if we're having multiple recipes, then an ingredient, like if we had potatoes, a potato would probably belong to more than one recipe. So technically that'd probably be a many to many relationship. But if we were just talking about one recipe has many ingredients, we'd want to put the recipe, foreign key for recipe, on our ingredient table. And then the last one right here. So let's say that we have a car example. So we have a table for makes and we have a table for models. So Honda Accord, Honda Civic, Honda CRV. Which table would have the foreign key and what would that be? Would make or model table, which one would have a foreign key on it?
Probably model, right?
Yeah, because one make or a Honda has many varieties of a model. Exactly. So if we had Honda, it could have a Civic or an Accord. So on the model table, we'd probably want to put like a make underscore ID on that table. Yeah, very nice. Cool. So it's 4:30. Let's take like 5 minutes. I just want to show you guys, Colin's going to go into a little bit deeper dive tomorrow. But before we go into lab time, I just wanted to show you how to grab data with two entities. So let's say that we have a books table and an authors table. How can I grab all of the books that belong to J.K. Rowling, for example? Let's take a look at how we would build some sample queries. So let me share my screen, and we're just going to walk through this one section, and then I'll put you guys into lab time. So let's see how these work. And we're going to play around with our library SQL, or our library database that we built earlier. And we'll walk through these real quick. So I'm going to share, let me find my terminal. There we go. Let me go back in there. That's not it. I want to share my terminal.
I've seen examples before where primary keys were made up of other data. Is that something you would not recommend?
What do you mean by other data?
I forget exactly what, because it was maybe 6 months ago I was doing that, but
like by an email or something, or like a username?
It could be that, like an email, since that's a unique thing anyways, or
sure.
Like going back to our book example, like maybe part of J.K. Rowling's name would be half of the unique ID.
Yeah, sure. Yeah, I think I understand what you're saying. So the best practice with the relational database, particularly Postgres, because of all the data, we're going to let Postgres manage creating the ID numbers. We're going to let Postgres, like every time we create a new book or new author, Postgres is going to like assign it an ID. So really the most important part of a foreign key or a primary key is that it's unique and it isn't duplicated. So kind of by default, the way to set this up is just to put the ID of a given row on some other table to show that relationship. But theoretically, sure, yeah, as long as the email is unique, or as long as the username is unique, you could use that as a primary foreign key relationship, sure. Yeah, theoretically, that'd be fine. And I think you can even, I'd have to look at the documentation, but I'm pretty sure you could build your schema and you could say, hey, use the username field as, like the foreign key or the primary key for this other table to show the relationship. Pretty sure you can kind of massage it to do that for sure. So really quickly, just want to show you guys how to set up a query. So when you're trying to query information from two tables, So in this first example, let's say that I want to select the, well, the first thing I want to do is find the ID of J.K. Rowling. So if I'm going to find all the books with J.K. Rowling's ID, let's get her ID first so we know what that is. So the way I could do that is I could do a select ID. So instead of, you know, grab star or grab all of the columns, I just want the ID from the authors table. And that should be capitalized in my lesson. I'll give myself lashings later, my bad. Where the name equals J.K. Rowling. Like so. So if we run that, again, the select set that's returned is only the ID for JK. So I know that the ID is 2. Now what I want to do is go into the books table, and I want to return all the books that have an author ID that equals 2, because that'll be all the books that belong to J.K. Rowling. And so the next step would be, let's select all the books from the books table where the author ID, so remember that in the books table, the author ID is the foreign key field, where the author ID equals 2. And so there we go. So that returns all of the books that J.K. Rowling is the author of. And so again, we're looking at data from the books table. So each Harry Potter book has its own ID. So this is the book ID and the publication date and the title. And then over here, remember that we added a foreign key field of author ID. And so now, as long as we know the author ID, it's really quick and efficient to grab all the books that belong to that author. So the author ID is all 2 here.
I have a question. So we always do like 2 steps, like first find the ID, then once we have the ID, then we go.
Not necessarily. If we were storing this information in a variable, we could like chain these together. I'm just breaking it out just to kind of, for simplicity's sake. But let's take a look at these other 2 examples. So right now we're only returning information from the books table. Let's say that we want to return all the books, but we also want to see data from the authors table and the books table. We want to see columns from both and create a result set that includes all of that data. So what we would use is a join statement. And this is what Colin's going to go over in more detail tomorrow. So let's take a look at writing a SQL statement using a join. So for example, let's do a select all the books from the books. So we're just going to grab all the books and join it with all of the author information. So select from the books, and we're going to join this other table. So we're going to join the books table with the authors table. And specifically, how are we going to join these 2 tables? How do we know what's related? Well, the way that we know how these are related is because we have that author ID foreign key on the books table. So anytime we want to have try to relate the data, that's really the important part. We need to make sure that the foreign key and the primary key match. And so if you look at this example, what we can do is we're going to join this information, but we're going to tell Postgres that the author ID in the books table should be the same thing as the author, as the ID field of the authors. So that'll be the primary key. So the authors.id is the primary key for the author, and it's also going to be the foreign key on our books. So if we run that, let me make this a little larger. Now we see that we have a data set. Sorry if that's blowing up your screens when I stretch that out. Let me make this a little smaller so it'll all fit in there. So now we can see that we have a nice result set that has all of the columns from our books table and all the columns from our authors table. And so now we get a result set for all of that data. So consider if we had an app and we wanted to print all of this information, you know, to a given view or a given, you know, print it to the browser, to the screen. If we set up a query like this, we would have all the information from both the tables, you know, that we could do something with. We could do, you know, an ng repeat over this data and, you know, print this all to the screen and such. And also, if you take a look, I think you guys should have this as well. I have that little colon at the bottom of the screen, the bottom left, which means that there are more rows that we can't see. So if you hit the space bar, it'll keep loading those extra rows and such. So we have 48 rows. So Colin's going to go over this in more depth tomorrow. I just wanted to, again, kind of prime you guys with this idea of foreign and primary keys. And that's really how we join, set up those relationships in a relational database. If it's a little heady, a little confusing right now, that's totally to be expected. It can get a little confusing. Where do you put the primary and foreign keys? But we'll get some more practice with this over the next week or so. So I have some lab for you guys, but are there any questions about what we covered this afternoon with like a one-to-many relationship, where to put the foreign key versus the primary key? We have rights, we need breaks. Sorry, man. Are you guys dying? Okay, my apologies. Well, you guys had like 20 minutes in the breakout. I assume you'd like stretch your legs and stuff. Okay, so do this. Take 10 minutes, come back. I'll talk about the lab, and then you guys can have some lab time. So my apologies. Don't go get unionized or anything. Don't report me. We'll see you guys in 10.